In this video, we are going to export a panel garment from Marvelous Designer in a format that is ready for importing into the Carbon garment processor in Maya. We are going to export three sets of meshes: thin simulation, thin flat reference, and thick flat render meshes. The process is the same for Clo3D as it is for Marvelous. So first we go into the UV editor, right-clicking the workspace and selecting Set UV Arrangement to 3D Panel. We need this in case later we need to extract the 2D panels from the 3D draped. Next, we need to check the mesh type. We can select a pattern piece, scroll down the properties, open the miscellaneous section, and here you can see these meshes are set to triangles. Simulations perform better with triangle meshes, so we definitely want our sim meshes to be triangles, but render meshes can be either triangles or quads. Here the mesh type is triangles, so we will export sim and render meshes as triangles. If your garment is in quads, check out the relevant video on exporting quad render meshes. Next, we need to check the mesh resolution, or as Marvelous calls it, the particle distance. Select all the panels, and if the particle distance number is grey, then they are all the same resolution. If it's red, then they are not. Okay, here are all the panels, and they have a particle distance of 5. 5 is a bit high resolution for simulation. Normally we would want to aim for around 15, but with something like these jeans, which will have tight creases behind the knees during animation, there will be a problem if we don't have enough resolution, because there won't be enough detail to represent the creases. So from past experience, we would recommend a particle distance of 8 for trouser sim meshes. That'll probably give us around 50-60k triangles for these jeans. Now, when we change the particle distance, that sometimes changes the 3D panel shape. So let's just check that nothing has happened. If, for example, a gap appeared in some seams, you have to briefly resimulate until the seams have closed up. That looks good, so let's select all the panels and export them as OBJ. We are using OBJ because that saves one copy of each material per garment, while FBX creates a copy of the material for each panel. We are exporting sim meshes, so we want patterns, we need the avatar, but we don't want graphics and trims. And we are exporting panels, so we want multiple objects. And these are thin meshes. And finally, we want unified UV. For scene scale, we prefer to work in centimeters. Right, let's finish the export. So now let's just check again that nothing has changed during the export when Marvelous synchronized. Again, it looks okay. Next, we will export the flat deformer reference meshes. To do that, we reset the 2D arrangement, and that gives us the flat panels. Now we can export these meshes as OBJ, just like the sim meshes. Finally, we need to export the flat render panels. Now for trousers with tight creases, we need a high-res render, actually higher than we like to export from Marvelous. Up-resing in Marvelous beyond a certain point is not great, as it starts inserting zero-size triangles, which are a bit tricky for the deformers to handle. So let's go back to a particle distance of 5, and then we'll do a final up-res in Maya. We export the render panels with graphics and trims, and we want multiple objects. We want thick this time because it's a render panel, and we don't need unified UV coordinates. Okay, export done. Finally, we just need to note if there is any additional collision or rendering thickness being set in Marvelous. Now we can move on to importing these meshes into the Carbon garment processor.